Hello everyone, my name is Yvette Hill and I teach at Springfield High School in Livingston Parish. I am most passionate about bringing opportunities for authentic and diverse STEM learning experiences to my students, most of whom are from a rural, low-income background. The lesson shown in this video is a physics lesson taught to a group of seniors. The standards for this lesson come from the Louisiana Student Standards for Science, and the resources for this lesson were adapted from the NASA Demonstrations lesson on Newton's second law of motion. The objectives for this lesson are for the students to be able to predict what will happen when a force is applied to an object of a different mass, and to graph force, mass, and acceleration derived from experimental data. Students will be expected to work together in a group to collect data over several trials and use their data to make a graph. Students will then compare their data with other groups and complete an analysis of the data, which they will submit to be graded through their choice of a written response or a video. Before this lesson, we have already covered Newton's first law, so this video picks up with a review of the first law. This activity was the first activity we completed exploring Newton's second law. Good morning. All right, so you should be getting your computer and your Avid binder out. You should be getting out your computer and your Avid binder to start our day. There you go. There you go. So what you should be doing, you should be logging in to Google Classroom, and you should be writing down our due dates and your homework in your planner. So that is what you should be working on right now. You should be writing down your due dates and your homework in your planner. I'm going to go ahead and take roll, and we'll be right back together, and we'll get started in Google Classroom, okay? Can anybody remember and tell us what Newton's first law covers? Inertia. Very nice. So what is inertia? What? You don't remember? Can anybody remember what inertia is? What does it have to do with?
Isn't that like a basic force?
It is the most basic law. It's motion, right? Inertia is if something starts moving, if there's no force acting on it, what's it going to do? Continue moving forever. Okay? So what do we think of when we think of Newton's first law a lot of times? We think of ice hockey. Or we think of space, outer space, right? That's where we think, that's a lot of times what we think of when we think of Newton's first law. Well, now today, we are going to be looking at Newton's second law, which discusses what happens when a force is applied to an object. So basically, Newton's first law says if there's no force on an object, what happens? It either stays still or it keeps moving forever and ever. Newton's second law looks at what happens if there is a force that acts on an object. So that's what we're going to look at today. So right now in Google Classroom, today we're going to be experimenting with some little cars, and we are going to be moving our cars on a track that you're going to make. So in your Google Classroom, you should see under today's assignment, it should say intro question. So click on intro question. And I'm going to give you a minute to think about that. Then you're going to turn to your neighbor and you're going to talk about that question for just a minute. So I'm going to give you a couple seconds to think about it on your own. So what do we think? The same force is placed on a heavier car or the lighter car, what's going to happen? Well, the mass is going to change. The force is going to stay the same. So what's going to happen to the motion of the car? Will the motion of the car be the same? If you had an 18-wheeler and a Prius and you moved them with the same force, would they move the same distance? Right. All right, so go ahead and read over those procedures really quickly. So you should be looking at the front. You should be reading. Okay, we're going to be taking What are we going to make out of our paper? A car. And what are we going to make out of our plastic straws? The track, right? So we're going to take our straws, we're going to cut them in half. Then we're going to do what with them? Lay them out like a track, right? So then what are you going to do with your car?
Put it on the thing and make it go.
Tape it up and put it on the track. Then what are you going to put in the car? Some pennies. Either how many pennies? 0, 5, 10, or what are we going to do once we get the pennies either not in there or in there? We're going to push air at it, right? So how are we controlling the force that we're applying to our car?
Giving the same amount of force for the total mass.
Same amount of force. How are we applying the same amount of force?
Take the air.
Using the balloon pump, right? If you pushed it, you wouldn't really be able to make sure that you're using the same amount of force every time. So by using the balloon pump, we are trying to control the amount of force that we are applying each trial. So as you're working, you want to try to make sure that you're pumping the balloon pump the same every time. All right, so now the fun part, right? We get to play the lottery. So go ahead and get out your little scratcher. Scratch off your scratcher. Then you're going to pick up your lab sheet, your scratcher, and a writing utensil. We're going to go out in the hall, and you're going to find your group based on people who have the same image as you. Okay? Any questions about that? All right, let's go. You can put up your computers for now. You can close them up, just leave them under your desk. Then you'll need to go down that way and find an empty table. You're with them. Okay. Good, okay. Let me find your alligators. Alligators. Caleb's got an alligator.
We got a fish.
That's a hamster and that's a bunny. So hamsters can go over there to that station. Very nice. All right, so how are we doing over here? Great. Which one are we working on? 5 pennies. So what do you expect to happen this time? Not to go as far. Why? Because the mass is larger. Are we changing the force? No. We're keeping the force the same, but the mass is going to be larger. Good. All right. So we're lining up for our next test. Very nice. So far, what have y'all tested? What test have you done? Just the 0. Okay. So are you seeing your data be similar for that test? Okay.
Trying to do it the same distance every time.
Well, so how are you trying to do it the same distance every time? What's causing it to go the same distance every time? The force of the air, right. So this is a very good strategy because you're making sure that you're giving it the same force every time. Good. She's writing down all our data. So y'all are finished. Very nice. So what did you see so far? What do you think? The more mass, the less it went. So was it like super obviously less?
Yeah.
Cool. So was that what you expected in your at the beginning? Good. Okay, so what you're going to be able to do is go ahead and go back into the classroom, and you can go ahead and calculate your averages, and you can do your plot down there at the bottom. Okay? Awesome. Got everything ready. What I want you to do is I want you, since we're not really still in our groups anymore, you're probably sitting next to somebody that wasn't in your group, or what I want you to do is look for somebody around you that wasn't in your group, and I want you to compare your data with theirs, okay? So go ahead and compare your data with theirs and talk about your data and how it was alike or different for just a minute. Well, so you didn't have the same data, but are there some similarities in the trends that you saw?
Yeah.
What are some similarities that you see?
Total mass is 0. They're about the same, but whenever there's like 5 pennies, then it goes down.
It goes down. What goes down?
The distance.
The distance. So even though your data is not exactly the same, that trend is still there?
Yeah.
Okay, good.
And we talked about just paying for it instead of budgeting.
All right, ladies. So let's look at your data. So did you have the same data?
Well,
No.
The first test, their average is 47 and mine is 22.9.
Okay, but what does that tell us, do you think?
We probably took a little rock and we blew it at different.
Maybe you didn't blow it. So you heard that, Myra? You probably just didn't blow it at exactly the same strength, which is okay as long as in your group you blew it the same every time. So, but did you see any similarity in your data overall?
Yeah,
The more mass, the less distance it went. So even though your exact numbers aren't the same, and that's okay, did you see the same trend over time? Very good. That's what we were looking for, was that trend. Good. After the video, students completed analyzing and comparing data with other groups and submitted an analysis into Google Classroom. Students were given the choice whether to submit their responses as a written response or using a video response through an online video platform. By collecting the students' lab sheets and reviewing these videos and written responses, as well as through questioning and monitoring throughout the activity, I can see my objectives of students being able to predict the motion of objects of different masses and being able to graph their data were met. This lesson is part of our larger unit on Newton's 3 laws. Throughout this lesson, I incorporate hands-on learning experiences dealing with inertia, friction, momentum, and impulse, along with pen and paper activities in which students perform calculations of essential physics variables. My Newton's Laws unit culminates with my students creating and launching water rockets, in which we explore the concept of thrust to focus on Newton's 3rd law, while also relating the rockets to the first 2 laws through the discussion of inertia, force, and acceleration. My students always have a great time with the water rockets activity, and I hope they bring all the fun and meaningful learning experiences we have in my class with them throughout their lives.